Hey, hello. I'm still preparing. I mean, the audio is still low. Increasing levels. More. Okay, yeah. So yeah, preparing the stream right now. I'm almost ready. I am almost ready. Just a few more things to do. Sounds good. Yeah. Yeah. Good. So, and now I want to promote this in Mastodon. Hey people, I'm starting a new Rasa stream for Advent of Code. We finished day 13, so that will be day 14. Oh yeah, it Mastodon. Yeah. I was sending some tweets today and yesterday, and I had to disable the notifications because I got like 20 in a row. That's how well it's going. So I'm getting a lot of good interactions in Mastodon. And what is my Twitch address? This is my Twitch address. And I can just copy the same thing to Matrix. Why not? I mean, same thing. I'm not even bothering to customize the message. And I know that I sent a message to someone. It was in direct messages. Okay. That sounds good. That sounds good. You got a good thing going. Yeah. Almost 400. I'm around 400 followers right now. Let me switch and enable hello. This is visible now. I guess like this will be good. Tools. Start this, and I guess that when I changes, and now it changes. Okay. Yeah, I mean, yeah, I have to be honest, I have been doing some stuff to try to get followers. So, like some stuff, like posting and so on, trying to be active, to say interesting stuff and reach people, and that has given some results, let's say. So yeah, good. So yeah, I don't know. Should I start already? Or any Any comments? Do we want to say something? So we have here day 14. The regolith reservoir. Hey, hello, Dido Grigorov. Okay, I hope I got. You want to change to Yami? I don't know. Dido from Mastodon. Okay, nice. Hello. Welcome here. Welcome here. So yeah, let's see. Do I have to change anything for day 14? Yes. There's an available update. I don't care. So yeah, I'll give some for every problem. I have template that I'm keep copying and pasting to avoid doing the same stuff again and again. It has two functions, some flags to basically be able to say which input I want to parse against, which part of the problem I want to do. Basic stuff that yeah, makes my life easier. I can do new terminal. Let's remove the other terminal. Cargo run binary day 14. Let's check that. Part 1 sample data debug mode. That needs a dash in here. That looks about correct. Okay. I will leave for now this music. Maybe we can change later. And I'm going to increase a bit the volume of the music because it's very quiet music. But yeah, let's. Okay. So let's begin. No, not now. I mean, it's end of the Sunday. I'm tired already. I've been working with the article for. So I guess I can show in stream. I've been working on this beginner's guide for Rust lifetimes. Writing a lot of stuff, and I'm very lost at the moment. So yeah, a bit tired. So yeah, let's take it easy. So yeah. Day 14 regolith reservoir. The distress signal leads you to a giant waterfall. Okay, actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Correction. The distress signal leads you behind a giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. The sun begins pouring into the cave. If you don't quickly figure out where the sun is going, you could quickly become trapped. This reminds me of Outer Wilds, because there was a planet that gets full of sand and you can get trapped inside of the cave system. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. You scan a two-dimensional vertical slice of the cave above you. Whoa. Two-dimensional vertical slice. That's a mouthful. It's hard for me to now to visualize how it's slicing in which axis. I guess it will become clearer. I discovered that it is mostly air with the structures made of rock. Okay, let's follow along. Your scan traces the path of each solid rock structure and reports the X and Y coordinates that form the shape of the path, where X represents the distance to the right and Y represents the distance down. Okay, that's good that we have the axis and the orientation of the axis, that's good. Each path appears as a single line of text in your scan. After the first point in each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point? Oh, so we are doing straight lines in 4 directions possible. Okay, so we have here 498 4, 498 6, 498 6. So x-axis is the same here, and y-axis is the same. This scan means that there are 2 paths of rock. The first path consists of 2 straight lines, and the second path consists of 3 straight lines. Okay. Specifically, the first path contains of a line of rock from this through that, and another line from there. Yeah, that's what I understood. The sun is pouring into the cave from point 500,0. Okay. Drawing rock as this hashtag or whatever it's called, or pound symbol or whatever, and air as dot, the source of the sun does plus, this becomes... Okay, I see that this is a kind of a map. Like, this looks like a bucket. Some sort of bucket. The sun will fall from here, and I will do some kind of small mountain of sand in here, I guess. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the first unit of sand comes to rest. Okay, so there is only 1 unit of sand in movement at each time. Unit of sand is large enough to fill 1 tile of air in your scan. Okay, yeah. Unit of sand always falls down 1 step if possible. Yeah, it will go down, 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 down until it hits here. If the tile immediately below is blocked by rock or sand, yeah, the unit of sand attempts to instead move diagonally 1 step down and to the left. If the tile is blocked, the unit of sand attempts to move diagonally to the right. Sand keeps moving as long as able to do so. If all 3 possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. Okay, understood. So driving the sand to rest as O, I guess. That's an O. The first unit of sand simply falls down and then stops. Yeah, that's predicted. The second one will do the diagonal left, so does this. Next one does right, and then left, left. Yeah, okay. Finally, only 2 more units of sand can possibly come to rest. That is because once it falls, it will go from here, from here, from here, will go here, here, it will go here, and then it will fall off a screen. Once all 24 units have come to rest, all further sand flows at the bottom, falling into the endless void. Just for fun, the path an innocent takes before falling forever is shown here with yes. Using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts flowing into the abyss below? Okay, I think I understand. What is the puzzle input? Interesting. Interesting. So this is the input, and the sample input is this one. Okay. Any questions so far? Anyone wants to say hi, ask anything. It's clear what we need to do. I mean, what we need to do right now is parse it. We need to parse this thing into something that is useful. So we see that how they are parsing it. The source of the sand. Yeah, for me, it doesn't seem really difficult. It's going to be elaborate. I have done things like this before, but yeah, it is a bit it needs a bit of work. So let's create a struct position that has X usize, Y usize. Actually, you know what? I64. I mean, usually we're not going to use negative numbers, but since that is easier than to clone copy for a position, now the question is, can I construct a constant for this? Like sand source as a position? Yes, I think I can construct a constant like this. 500, y is 0. Yes, I can. Okay. That is all. Now we need to parse this. So what do we parse this into? So there are several steps for parsing this. First is parsing this into basically converting this into something in binary in memory, and then drawing it is a different matter. So we need to parse it. We should parse it in steps. Doing too much stuff at once is bad. Just do one thing at a time. So it's basically we're going to return a vector of positions, a vector of positions, something like that. Like a vector of positions, and that is because we have something. Let's copy both lines. So we are going to have something like this, which is going to be converted into pos, pos, pos. So like a vector here, and then another vector pos, 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 like 4 for the second line, and then you will have another vector that will have all those inside. That's why we have a vector of position and then a vector of vectors of position. Let's just call the function debug the contents that we get back, and for now let's implement here a to do. So stops telling that my code is wrong, because I know my code is wrong. So far so good. Now that this doesn't look like progress, but it is progress. So first thing, for lining contents lines, okay, and then for each line, text positions are basically line split by I mean, I think it's guaranteed that it's going to have a space, so let's just do that. Collect into a vec of something. Let's debug these text positions for now and see where we are. That does look good. It does look good, yeah. Okay. So if we can parse this into a position, like we can just here implement position and do a function from str. So as is %str, that's that returns self. So let's say that we receive this. Then how do you construct here? So you do s.split by comma. Okay, and that should give me 2 values. Now I can do, because this is an iterator, if I'm not mistaken, that's an iterator. The iterator needs to be mutable as usual. And then you can do self. So first coordinate is x, second is y. So x is iter next parse, unwrap, parse, unwrap. Okay, and same for y. And then that will do first part for the x, second part for the y. That should be maybe I should not care about errors here. Let's just check that it works with both, and if it doesn't error out, there's no point of spending time on that. Like in real code, I would like to put their proper error handling, most likely to return a result. But yeah, I mean, those are simple exercises, and doing it totally correct takes too much time. What we can do here is basically map it using pos from str. And now, just with this map, because this type is automatic, that should have changed the type. And now we have positions. So, yeah, one step less. And if I test both, if I test also the real data, it will be very long. Yes. Not yet implemented, 68, that's correct. Means that we reach this part without any kind of error. So, no need for handling errors, because the only 2 cases that we cared, the only source files, they work. I mean, I said, on a real program, real things, that's not acceptable. For such a simple thing, it is perfectly fine. It's gonna work. I'm moving on. So yeah, this creates the vector already. The internal vector is created from here. Yeah. Which reminds me that this one can create me the other vector. I mean, why not? So if I do collect into vec whatever you want inside, so yeah, this one can go away. If I do this, then I can just do everything in one go, lines, then map for every line, then you do this and collect, and the result value should be already the right one. So if my theory is correct, I can just do this, and that's it. And now this doesn't error out and gives me the array that I wanted, just in one go. Nice. And this one works too. Okay, first parsing is done. Okay, I don't know. Feel free to ask questions or something. I mean, we don't have any comments. I'm just moving on. This is very nice and it has been very quick. Knowing this syntax with iterators helps a lot. But it requires practice. So this is the first step when parsing. Now we have objects that we can actually manage. Now the next question is how to handle this kind of board when handling it. Like how do I handle that in memory? Because there are two ways. One is to have a vector or an array of X amount of size in memory and just access it in memory. That's one way. But then it has to have region of that can work, min-max region or something. Because yeah, if it goes out of bounds, if it just asks for something that is outside of what we can store, we have a problem. The other option is to have a hash map. With hash maps, we can have the board infinite because we only need to store the non-zero values. The problem is still that we don't know when it exists the board at all. We don't know when it's falling outside. So I'm not sure if it saves us too much, because in the end you need to have a size. In order to know when it falls outside, you need to have a size. I don't know. Any ideas, any suggestions, any preferences? I'm really tempted to use just regular arrays. Like the hash map has the advantage that it only stores non-zero values, so you can store very big data that is very sparse, when in arrays you cannot. But I'm looking into this, and all the numbers that I'm seeing, they look pretty similar. In fact, why not? I can compute a min and a max for the 4 coordinates that we are going to touch. Let's try that, because that will give me an idea. So something like let mut min x i60 equals i64 max min y max min. Okay. Can I flatten an iterator? Rust flatten. Whoa, there is a flatten. Nice. Let me try it. So the thing is that I have now here a vector of vectors, and for this purpose I only need a regular vector of everything together. So because it's getting in the way. So I could do contents iter flatten, okay, and then let's retrieve the x value. Let's call it p. So it's retrieve the x value and then compute the minimum. Unwrap. Huh. Hey, not bad. Not bad at all. Not bad, and this is already useful for the next step because we need to know with what size are we working with. Now they don't need to be mutable because the competition is done. Of course, this is not super efficient. It's not 100% efficient because we are iterating 4 times to get the 4 variables when you could just iterate once and get the 4 out. But the difference is near 0 in practice because we're doing this only once. The amount of data that we are working with is not that big. Can do here contents len to see the size and min x, min y, max x, max y. So yeah. So even for the full data, this is the full data. We are working with 174 from 475 to 536 from 12 to 178. It's not that much. Really, I think we only need a vector or an array, and that's about it. We don't need that much. So I could be freaking lazy here because, like, in reality, it only has 536 minus 465 is 71, and 178 minus 12, 166. It only has 71 times 166. Okay, so it's 11,000 squares that are possible. I mean, I could be even more lazy, and I could do something like 600 times 200. Oh, wait. Yeah, I mean, it's not that big. That is 120,000. It's not that big. I mean, I'm not being really efficient here, because I could just allocate these and do offset corrections. But the thing is that I don't really need to, because the amount of things that you can store are 3. There are 3 states. There is 0 for air, 1 for rock, 2 for sand. And in reality, you don't need even to differentiate rock from sand in this algorithm, or at least so far. So you could just store with with 1 bit. You could use just a boolean. We could use just 1 byte, which is like 255 options to store that. We need to check if an enum will do 1 byte or will do 8. I'm not sure, but I think it will do 1. The thing is that 1 byte times 120,000 is basically, so if I do that times 1 byte, if it's to be correct, and we go to transform this into kilobytes, is, well, less than 120 kilobytes. Twitch just told you that I'm live? Yeah, okay, yes. Hello, I'm live. So yeah, I don't know why. The connection seems to be fine. 30 minutes late, Twitch. 30 minutes late. So yeah, I mean, this size is very much manageable. So I don't think I need to care. I mean, the problem is that if the second part gets more complex. But the thing is that even if the second part gets more complex, the data is most likely to be the same. So far has been the same. So I don't expect it to increase. So why not? make things simple. And if not, we'll have fun and we will refactor, you know? That's what I think. So in a map, you will have data of wait, extract cell, let's call it cell, or how it's called here, So saying that the think it says we're saying that it fills one tile. Okay, fills one tile. So let's call it tile. And this is an enum, which can be air, rock, sand. Right, so here, rock as this, air as that, and sand as that. Okay, yeah. Those are the three possibilities. Okay. So the data is no. Let's try to make an array. An array of an array. So the inner array first will be easier. The inner array is of type tile. I want to go down. So let's make it 200. And then the next one is like this, but it has 600. Oh, you know the problem? You know the problem? This does not fit. Might not fit on my... give me problems on the stack. If I create the map on the stack, the data might be too big. We might be copying too much and doing too much stuff. So maybe just create you know, I don't like the vec of vex. You know why? Because it's you don't have any guarantee that the inner vec has the same size across all the possible rows. So you could have by mistake some rows that are shorter, rows that are bigger. And I don't like that. I don't. And really, really don't. Anyway. Min x. Okay, let's do I64. Min y. I64. So function new. So we get C, which is of the type vec of vec. pause. We'll see how that goes afterwards. And we can compute those using this. Oh, that's okay. Doesn't matter, doesn't matter. Okay, now we are going to create the empty map. Let data as a veg of tile. And in theory, you can here make, for your hit, we were talking about this before, you could make, instead of creating the empty one like this, you could make, if you know the size beforehand, you can do vec with capacity and say, I want a capacity of max x plus 1, for example, as your size. And then I will make a vector that is empty, but is already reserving memory for enough data to be held. So it doesn't need to recopy the data in every time that we exceed the size. So that's a bit faster, but that's only important if you call that a lot of times. So really, I'm going to leave it like that, but usually I don't bother. At work I do bother because they check for that, so they want me to do the with capacity in Go every single time. Not that it matters, but if you have code that is running in a loop and is creating this very fast, it does matter. So because we want to do data x, y, this is what we want to do. So we need to do first the for in x. For x in from 0, we want to do from 0 to and including. Oh yeah, because the position, so this is that position. So max x will be this position here, 503, that lands here. So this position is still valid. So when you make the capacity, you need to count for the 0, I'm going to reserve for the 0, and then you need the +1, because if not, this will land outside. So you don't want to create capacity for this and leave this alone, right? You want to create the capacity for the whole thing. Because I'm creating this from 0. I'm not doing from 494. I'm doing it from 0 to 503, which means that it needs 504 items. So we need to include the 0. The off by 1 errors is the most classical one in programming. And same here, I'm including the equals in purpose. That's not accidental. That equals serves the same thing as the +1. That needs to be mutable. In fact, the inner ones are very easy, because the inner ones, the y vector is basically a vector of tile 8. I'm not going to fill it now. How many times? Max y plus 1. And he doesn't like me. Okay, that's as you size. And now, what is your problem here? Clone is not implemented for tile. In fact, this should implement clone and copy. There is no point of not being able to copy it. This one, for example, should not implement, well, cannot implement copy, and it should, because data is very big, but vectors don't implement copy anyway, so you cannot implement copy. So clone is fine. I mean, if we clone, we don't want to clone map because it could be expensive, but if it needed to be, I mean, why not allow it? It's fine. It's fine. We just know that if you clone a map, it's slow. Just don't clone it all the time. Maybe clone it once, clone it twice. So yeah, just with that, I can just do data push yvec. I mean, to be fair, this can be summarized much quicker because I think that this vector can be put inside another vector. Like, it doesn't matter. It doesn't matter. Why worry? Why worry? Yes, you can make the creation here in just one single line, having one vec macro inside another vec macro. That should work. But why we should push it too hard? It's enough. It's enough. So we got our new data. So far, we don't seem to be needing that. So I'm going to reduce it, because why? And then we are going to return this self, and then data max x, max y, and return here self. So now we don't need this. We don't need that. So let map equals map new from contents. We consume the contents, so we don't need them anymore, and we can try to debug the map and see how far we got. I want this time the sample data, please. I don't want something huge. I mean, it's gonna be huge anyway, right? Because it's gonna display everything. But yeah, okay. Maybe for displaying, it will be good to have minimum and maximum. Let's bring them just in case, because it's gonna be handy. It's going to be handy. So I want to print that better. So implement tile, and let's convert that into string. Function to str, ampersand self returns ampersand str. Now here we have the problem with the lifetimes. That lifetime is unclear from where it comes from. But the thing is that what I'm going to do, so let's see if here's the code, is basically a match over self, implement all of them, and well, it doesn't complain because it has here the borrow, so it thinks, yeah, okay. So here is gonna be dot, drag is going to be this, and sun is going to be plus, just like in the problem. In this case, we can also put this lifetime static, because those are constant. So you can just say static, and now the return value of this function, it will not check whether this tile is alive or is not alive. This is one option. The other option is to char, and then you just do return char, because it is one character. I don't know which one I'm gonna use. Both look nice. Yeah. So the thing is that I want to be able to print it, like in debug mode or something like that, or in display. I'll print the display. This could just implement debug for map missing members. And then this does .field. Very nice. I don't want that. I really would like to learn how this debug struct works, because this looks nice. But so this uses the other formatter. So this returns a debug struct, and this returns a debug struct again and again and again. It will be looking nice if you know. Yes, the bug is derived twice. Now not anymore. Yeah. So far we have the same. Now. The problem is with this data. I don't want that. I don't want that. So, okay, let's comment that. Yeah, I would like it in here. But I mean, I only see build and into and deref and build. You can put whatever. And this is expect something that allows debug. Let's save this FMT like that, mutable, and then we can do this. You don't like that. Need to be mutable. Not now, but oh, okay. The story easily. It complains in every single line. Self returns mute self. No, wait. You do that. Here is the thing. You do that, and then oops. Let's see if I. Sorry, I'm learning this on the spot. It looks like I'm confused. I am really confused because I never did this on the spot. So I think this is what it looks like when you want to control it. Yes. That looks okay. That looks good. So now... for y in from self min y to and including, don't forget, self max y, and now for x in self min x to and including self max x. Okay, now we need to collapse this into a tile. Character is going to be just self data xy. You don't like me. As you size. You know what? There are no negatives here. It's impossible. I'm doing something stupid from the beginning. This is going to be easy just if everything is your size. That's okay. That's okay. Next one. Okay. And now that has a to char or to string. Let's do a to char. So this is basically, so this is an iterator that can be mapped because that returns x, and then you can do that, and then you can collect into, yes, I know that my code doesn't make any sense right now. Stop underlining in red. Let draw as a vec of something. Well, it's a vec of char. Should be a vec of char. Is this? Yes. Now draw. Wait. I want a string from that. Let's just search vec char to string. Stack Overflow will tell me straight away. Oh, you can collect into a string. See? So as simple as, instead of collecting into that, I can just collect into a string. That's magic. That's freaking magic. Let's collect into a string an iterator of chars. Makes total sense. Super simple. So now fmt field, and we put here, this is an ampersand str. Name is going to be format, and row okay. Row here 03 to make 3 0 digits on the left, and it's going to be y, or something like that. Underscore. I don't know. Let's search later. So now I can put here the name, and now the value is just row, and that works. So if I'm not mistaken, I can do this. Okay, y goes from 4 to 9, and this displays the map. If I go for the full input, yeah, we have a full map. I mean, not bad, right? Not bad. This is easier to debug than the other versions, so we can check what we are doing. So far so good, no? We learned something. One or two things. Yeah. That looks good. I'm going to get rid of that. Next, we need to draw the walls in here. We need to draw the walls. So, to draw the walls. So that is rocks. Yeah, wall in contents. I'm going to do iter instead of the ampersand. Stop complaining. Come on. So this gives me a list, but then a line is made with a source and a destination. So I need pairs. So that is for src to dst in wall. This is a vector. Then that should have windows of size 2. That should ampersand or iter, yeah, or dot iter. Oh no! Wait! What is your problem? Of type pos. Ah, yes, because it returns. It doesn't return that. It returns. Yes. Those are rect, and then let us see dst as rect 0, rect 1. Parenthesis, please, to make it a tuple. Okay. That looks good. Sample data, please. It seems I'll have some time tomorrow. What I will be up to? I'm not sure. I think I will have time. And the problem is my calendar for next week. Let me check in the phone. Man, the other phone. Since that I don't have it in my regular calendar. I should put this in my regular calendar. Yeah, I have Monday and Tuesday available. Wednesday, I have 0 guarantee for anything because I have something scheduled. And I got Thursday off. Probably most of the Thursday I can be at home doing streaming or something light. Because I have something to do with the hospital, something very simple. But I will be still probably recovering on Thursday, so I will be probably doing something very light. But yeah, maybe we'll do gaming, or maybe we'll do a string programming or something, but something that doesn't stress me too much. So yeah, Wednesday is a no. But Monday, Tuesday is okay. Thursday probably will have most of the day. So yeah, I wanted to see. Yeah, it's quite routinary. I mean, it's basically some kidney stones that need to be get rid of. But yeah, it should be okay. I will be fully asleep, so that's the thing, because I will get general anesthesia. I will be out for most of the day, and the next day I just want to keep it easy because from the anesthesia and so on, the next day I want to be easy. Monday, yeah, okay, yeah, good that you tell me, because that means that I need to be at home at that time. So if I go to the office, I need to come early, or probably, most likely, I will be working from home. Yeah, kidney stones, yeah. They are not fun. When they are not moving, you cannot notice anything, but when they move, oh man, that hurts a lot. So yeah. From what I'm told, the operation is like a breeze. So yeah, I don't expect any problem. So yeah, 498 or 498.6, and then from 498.6 to from 96.6. Okay. Okay. So we will do something like data. Oh, I would like to work in positions, not in coordinates. So I can create a function. Oh, I cannot because it's not constructed yet. Crap. Crap. Haha. So let's do it manually. Data src x src y equals tile rock x and y tile rock. Yeah, because the source is going to be. And now what we do is. Mutable src. If src x is less than src dst x, x minus equals 1 minute. So I'm thinking that this is a lot of code that do I want to make this better? It's going to be more readable, but sorry. No. If it's less than, needs to be incremented. If it's greater than, needs to be decremented. And same for y. This is not optimal, but hey, Patatas, hello! How are you doing? So much time no see. I mean, not that we see you face to face, but I mean on the chat. So yeah, yo Patatas, hello. Hope you're doing good. So yeah, now we move one position. Move one pos towards DST. So, and this will be while SRC is not the same as DST, keep doing this. Okay, the problem is that it cannot make this difference because it needs to do .x and .y. But here will tell me I need to implement partial egg. But this is one of the things that Rust can implement for us. Everything. Partial egg, partial ord, all the traits implemented automatically for us. How nice is that? How nice is that? Fantastic. Totally fantastic. So I'm thinking that I can move this here, and then this will keep moving it until it finds the destination, and on the last step we are in the destination. Let's write the destination. And then I finally ended something that I was doing for a long time, so pretty liberated. Okay, maybe you finish some project, you finish something that was big, that was okay, that's relieving always. Glad to hear. Very glad to hear. Amazing. Oh, this looks like the thing that we got in the problem, right? I mean, this looks so similar. Let me check. Yeah, you see? Looks correct to me. Wow. So if I pass the full input, what do we get? Oh, they are evil. Oh. Okay. So I guess that it's gonna fill over here. Oh man, we should start from x equals 0. This is... Yeah, we should start from from y equals 0. Meanwhile, it's gonna be 0. Because it's gonna start from here and it's going to create a small mountain in here. We want to see that. So yeah, it's gonna fall in here, then fall in here, fill this container, and it seems that it's gonna fall on the right side from the design of this, gonna fall from the right side, and then from both sides, and then fall from here, same story, fall something here. Ooh. This looks like the this machine something game. How it was called? This crazy machine that you could make crazy machines, but I don't know. It looks nice. Interesting problem. It seems that it has drawn properly. Okay. Hey, hello Manu. Hello from YouTube. How are you doing? Hope everything is good. Here with Advent of Code day 14 we have the thing drawn, and this is the problem that was given to us. Yeah, so good. So now I'm thinking like, yeah, the sand. Yeah, I'm doing good. I am doing good. Just a late night stream as usual. Relaxing, doing some Rust just to pass time, and I don't know if anyone can learn anything from me here. That will be good. But yeah, nothing too crazy. Should you subscribe? I don't know. Subscribe. I usually do. I'm lately doing live streams with Rust. You want to subscribe? Go and subscribe. You will find mostly lately Rust live streams. You will find some gaming. I have been doing Kerbal Space Program 2 is coming soon in February 26th, I think. So expect a lot in YouTube from me on Twitch as well for Kerbal Space Program 2. If you don't like the game, I'm sorry. I mean, that's like, my channels are not thematic to anything in particular. It's whatever I do, I like posting, they go to the channels. I have no filtering. I also do music. I have another channel for just posting songs, but that's about it. So yeah, up to you. I don't want to be like the common YouTuber that is here like pitching, please subscribe and hit the bell button. Come on, no need. If you want, you know what you want to see in your timeline. You want to see this in your timeline, you know what to do. Okay, chatting a lot. You sub in 6 different accounts. Okay, fine. Okay. Okay. You will be kind of half of my subscribers if you do that, I guess. Well, not half, but yeah, sizable amount. Anyway, yeah, legend, total legend. Wow. So this needs the moving sand. It's called moving sand or falling sand. Let's call it just sand. Sand is a position, yeah, and it's guaranteed to have a position. Always there is moving sand. So where is the sand? The sand by default is in the sand source. Okay. Then when we draw, it will be interesting. It will be interesting that we can draw the sand. Oh, okay. The moving sand is plus. The fixed sand is O, I think. Yes, fixed sand is O. So it's called fixed. How is it called? Or just moving sand. Okay. And now, of course, it has to. I mean, I'm not using this one, so why bother? Why bother? So moving sand is plus, sand is O. Now the key is that when we draw, I want to see the sand, the position. So on the debug, so on this data XY char, there is a difference here. There is a difference. So we make a position if a pose XY equals self sand, then else that we convert that into char. So this will be moving sand. Okay, I'm trying to match at the same time. Surround the struct literal with parentheses. Okay, at your order. Oh, okay. So I can get the enum from here or from here and then to char. I was thinking of doing the to char here and then just placing here the character. But then, I mean, it's true that we don't need to store that fourth option here. But it's nice that we have all the characters in the same place. The same conversion in here, so meh. Okay, so we can see the falling sand in here, we can see the falling sand scroll up here, and we can see the falling sand here. Okay, that sounds good. So it seems that we are around time to start creating the logic. So if we do a function step, let's call it itself. So let's put some documentation. Move the moving sand down until it's out of bounds. Then spawn a new one. Only one movement and is done per function call. we will figure out more stuff later. So now, so we have self sand, which is the position of the current one. So we'll be checking below. So we'll check below. If self data was, let's call it P, px py plus 1. If that is air, let tile air is this. We cannot do that. Complaints. Oh, equals. Yes. Sorry about that. So if that one is air, just move it down. Let's do one thing at a time. Then it's gonna look a bit strange. Check the left diagonal. It said first down left, then diagonal left, then diagonal right. Right? Let's double check. It's blocked, then to the left, and then to the right. Okay. So it's first left, then right. Okay. So if we reach here, we settled. So if we settled, then the current position, this one is gonna be equals to tile sand. So it's gonna settle, and then we create a new one. Yeah, that looks like the algorithm. The problem is if it reaches out of bounds. So if it reaches out of bounds, that will be here, for example. So it's gonna return a boolean. So let's return true. And we no, don't like it because what is this boolean? What it means? Is sand out of bounds self, and then that returns a boolean, and then we understand that this has to return true when the sand is out of bounds. So that will be sand y is greater than self max y. So the thing is that if we are sure that there is no platform below possible, then it's out of bounds. So actually that's it. No need for anything more. That's it. That's the condition that returns true when it's out of bounds, otherwise that returns false. That's it. Thanks for coming in. That's done. Thank you. Next, we are going to call step and this send out of bounds. So back to the program. So or loop or whatever. While map is out of bounds, well, that was not out of bounds. I'm gonna keep iterating and do map.step, and gonna do the bug map, and that needs a borrow because the bug is special and needs to be mutable. Problem done. Next problem. Oh, out of bounds. Okay, anyway. The len is 10, but the index is 10. Yeah, so it's gonna try to write a bit longer. That's more or less fine. We can try to fix it. No, it's trying to read. It's trying to read a bit longer. What? I'm not looking into the browser, okay? I'm looking into the code. I'm reading here. If I go to the browser, that's the browser. If I go to the source code. It's just that I'm talking on the source code all the time. I don't know if I'm going too fast. Maybe I'm going too fast. But yeah, len is 10, but the index is 10. So the safe thing to do is basically when we create okay. Well, also it also places the cursor in the browser at the same time, but it's behind my window. Anyway, yeah. This is just to allow checking the last rock, because I don't want to implement that properly, so now it works. Okay, that's working, and we can see it falling over time. Oh, nice. So you can see, like, it comes from here, it's here, and now it moves down, then rolls to the left, keeps rolling to the left, keeps rolling to the left, to the left, to the left, down, and to the left, and out of bounds, so we finish. Okay. Next thing is counting how many there are, how many sand there is. So let's comment this out for a second and let's debug it afterwards. Let's see what happens with the full input. What? Is this correct? I would expect the others to contain also sand on the right. Of course, because it rolls to the left, but it should also roll to the right. Is this being blocked in here? mean, this has stopped because it has rolled out of bounds, so all the sand that comes goes out of bounds. So there is no point of continuing because everything else is gonna go out of bounds. I'm not sure if I got anything wrong. Let me check. Does this make the same shape? No, it doesn't roll to the right. See? This gap here, that's a bug. Oh! I didn't put the right diagonal, so I had the left diagonal twice. That is the reason. Now, yes, now it matches here. Now in here, does it make sense? What? It errored out, right? This is the problem. Index out of bounds. Towards the right as well. Yeah. Towards the right. The probably the margin only needs to be 1, not 2, but now this looks different. That makes more sense. Yeah, nice. Yeah, that looks more or less correct. Okay, so all that's remaining is counting. So let's count. Map data iter flatten. We want to filter if x Can I do? I don't think I can do. Sand. I'm not sure if I can do that. Filter and then count. That should be usize. And as expected, this cannot be applied to ampersand percentile, but I can do cargo check. I have another problem here. I remember. So, oh nice, this is style and this is style. Yeah. So in theory I can do this, but now the error is different, right? Must implement partial egg. Ah, it's just implementing partial egg. Come on. How I... It's very simple. Then it's very simple. Why I was complaining so much? Yeah, of course. Of course, because we're going to debug it. Sample data 24 we get the full data 913 913. Is that it? That's the right answer. Nice. I'm going to stop for just 2 minutes, maybe 5, but very shortly. I'm gonna be back. So yeah. See you in a second. Okay, I'm back. I've been reading slightly the part 2. I'm like, son of a... This is evil. This is really evil. Very evil. Oh man. Just screaming me like crazy. Remember I said like, the input data is the same. It cannot grow. Yeah, it cannot grow unless you assume an infinite amount of ground from the left and to the right. So yeah, hey Olgi, hello. Thanks. Yeah, sounds promising. So the array approach, I'm going to try it. I'm going to try it anyway. Because in the end, this can create a mountain that is a pyramid. So if the 8 is 400, it can only move 400 to the right and 400 to the left. And because this is in position 500 in X, I have enough positions to go to the left. So I think I don't need to go to implement the hash map here. I would like to avoid it, if possible, whether possible. But yeah, let's read it. So let's go and read it. So part 2. You realize you misread the scan. There isn't an endless void at the bottom of the scan. There is a floor and you are standing on it. You don't have time to scan the floor, so assume the floor is an infinite or horizontal line with a y coordinate equal to 2 plus the highest y coordinate of any point in your scan. This is good because I do have the maximum in y, so this is easy to do. In the example above, the highest y coordinate of any point is 9. So the floor is at y equals 11. This is as if your scan contained one extra rock path like minus infinity, 11 to infinity, 11. With the added floor, the example above now looks like this. Yeah. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes at rest at 500,0, blocking the source entirely and stopping the flow of sand into the cave. In the example above, the situation finally looks like this after 93 units of sand come to rest. Using your scan, simulate the falling sand until the source of the sand becomes blocked. How many units of sand come to rest? Amazing! This is just amazing. Great problem, great problem. So, back to sample input. And we'll do part 2. To do part 2, let's just copy. Remove that and remove the underscore. So we have an equal part 2. It's the same thing as part 1. So now we are doing part 2. Yes, so the thing is that, yeah, our map needs to support both modes. Somehow, needs to support both modes. So, let's call a mode, program mode, part 1, part 2. Then we call here mode, program mode, and store the mode here. That is mode. And now that's program mode. That needs to derive clone because this one derives clone. I don't know if I need to derive anything else, but so far program mode part 1, and this is program mode part 2. So I can support both things. Okay. I don't know how much of the mode I will need. But yeah, anyway. Margin X needs to be... Yeah, that's no longer a constant, so... Because it needs to increment also plus max Y. So... I mean, we could do this for both. There's no... This is just for the pyramid that we were talking about. This is the maximum it can go right. No, wait. No, that's not the maximum. Map max X is this one maximum with the source of the sand source. Am I doing something wrong? Why is not completing? Oh, is that the source? Point X, so from where it starts, plus max Y plus 2. That is how maximum can go to the right. And then you do that plus margin. That can be common for both. I mean, that's not a big deal. That so part 1 should be still contain the same. Maybe slower because we are going to hold more data. Other than that, that is fine. That is fine. When printing this, we will do if self mode equals tile program mode part 2, and then yes, that needs to implement partial egg. Okay, we want to print the let y equals self max y plus 1, and we print exactly the same. So and now print the ground, which is plus 2, and now for the same thing, and now for every of those we just print here it should be to make it correct, it should be rock and then rock to char, which is basically the character. Collect name, format field, and I don't need that X, so that's underscore. So now for part 2, so part 1 should stay the same, part 2 should print the ground. Also for part 2, margin X is match program mode. So we want some margin to see from the left and the right because we can get a bit extra here, so we want a bit of visibility. So that's 0 for the regular one. Let's say 10 for part 2. And then min x is self min x minus margin x. Max is max plus margin x. And now you can just do this. Min max, min max. So hopefully we will see a bit more in the part 2. Yeah. Okay. Looking good so far. Now we need to compute this. We need to compute when it's blocked. So function is send blocked self bool and send is blocked if we grab self data where self send source x and send source y if that is equal to tile send. So if we store send there, that is blocked. Sorry, no semicolon. That's the condition. So we do that until it's blocked. We step until it's blocked. Now this step, the problem is that it needs to account for the last how do I emulate that? That should return rock in that case. Could move that into a function and do the resolution in a function, or because theory. If basically if p.y is self max y plus 1, no, if it is less, so So self mode needs to be equal to program mode part 2 to enable this. Oh my god, oh my god. So yeah, so the bedrock, so is bedrock is if we are in part 2 and py equals that. Yeah. So if it's not bedrock, you compute this. Not you settle. And now we compute and we explode. No, we don't explode. It does the nice pyramid, sun count 93. Sun count 93. Okay, I'm gonna trust it. Wow. Yeah, the margin is not enough to show how much sand is in here. So, and as expected, this can create a pyramid to the right, starting from here. So that's what I was doing, like this 500 plus the 178 is how too far to the right it will go. Yeah, 30,762. Let's try it. And that is the right answer. We finished. Okay, I don't know. What do you think? Did you like the problem? Did you understand the problem? It's the harder question here. Yeah. Completed day 14. In 2 hours, yeah. I mean, relaxed 2 hours. I was not rushing, but yeah, in 2 hours, I didn't find it difficult. You gave up trying to understand, yeah. 10 o'clock here. 10 o'clock. 2 hours? Yes, 2 hours exactly on the clock. Try to pick up a few things here. There. Yeah, that's good enough. That's good enough. That's good enough. 15. Because why not? I don't know. I still have some time. Let's see. Day 15. Beacon exclusion zone. You feel the ground rumble again as the distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you don't need to. Your pack contains a set of deployable sensors that Imagine were originally built to locate lost elves. So I have deployable sensors, okay. Sensors are not very powerful, but that's okay. Your handheld device indicates that you are close enough to the source of the distress signal to use them. You pull the emergency sensor system out of your pack, hit the big button on the top, and the sensors zoom off down the tunnels. Once the sensor finds a spot and thinks it will give a good reading, it attaches itself to a hard surface and begins monitoring for the nearest signal source beacon. Sensors and beacons always exist in integer coordinates. Each sensor knows its own position and can determine the position of a beacon precisely. However, sensors can only lock onto the beacon closest to the sensor, as measured by the Manhattan distance. Wait, the Manhattan distance is the cap distance? This is the taxi cab geometry. Yes, understood. Understood. I know how this works. I I know how this works. So yeah, when you count with the Manhattan or taxi cab geometry, when you count for the length, you basically count one up, one right, 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 one up, one right. So instead of doing this, you count going in a square, so which is basically the same as counting all up plus all to the right. So yeah, it's not Euclidean, it's another kind of distance, but it's simpler than the regular distance. So yeah, because the sensor is measured by the Manhattan distance. Okay, it doesn't take long for the sensors to report back their positions and closest beacon, your puzzle input. Sensor at this position, closest beacon at this position. So this is the delta. Drawing the sensors and beacons B, the buffer arrangement of sensors and beacons looks like this. This is not necessarily a comprehensive map of all beacons in the area though, because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know there are no other beacons that are close or closer to that sensor. There could be still beacons that just happen to not to be the closest beacon to any sensor. Consider the sensor at 87. So this is the range of this sensor to get into this beacon. So that means that there are no other beacons in here. Okay. None of the detected sensors seem to be producing the distress signals, so you'll need to work out where the distress beacon is working out where it isn't. For now, keep things simple by counting the positions where a beacon cannot possibly be along just a single row. So for example, suppose you have an arrangement of beacons and sensors like in the example above, and just in the row where y equals 10, you'd like to count the number of positions a beacon cannot possibly exist. For example, in the row 10 there are 26 positions, so those I guess, where a beacon cannot be present. You consult the report from the sensors you just deployed. In the row where y equals what, 2 million? Yes, 2 million. How many positions cannot contain a beacon? Okay, that number is ridiculously big. That's getting me scared. Get your puzzle input. So now there is no point of graphing this. There is no point of graphing this. Okay. Sounds good. Sounds good. I'm getting I don't know the word wary, afraid is the word. Getting afraid of this problem already. So let's fix a few things. So this is day 15. Let's grab sample input and the real input. Sample input and the real input. Okay. So first task obviously is to parse this. And I am filling regex. I am filling regex at this point. Because why should I care about this? I'm filling regex. So let's convert this into something. So sensor data. Sensor data has position, and that means that we have a struct position that has x i64, y i64. Now is i64 for sure. We do have negatives, and this needs a derive, debug, clone, copy, partially Q, and everything full-fledged. This one we don't need equality, but clone and copy will be nice. So it needs a position and needs a beacon position. So now we need to transform the text into that. So implement sensor data, function from str or from line, let's call it, which will be str, return self, to do for now. And we are going to do something like let sensors is a vec of something that is contents lines for each line, map sensor data from line, collect, that should collect into the vector. So far so good, types match, we are on the right track. We could do here a debug sensors. For the time we can actually run this for real. So part 1, sample data, day 15. Yes, spanning as not implemented. Yes, that is correct, that is correct. So to do a line, I always forget how to do regex here. I think I have already a model for regex. I just need to use it. So let's pull yes, and I have, let's copy this. This is what I want. Let's see what is the code I just copied. Let's see static regex, yes. Let's put it in here. Okay, it auto sorts. Good. One thing less to care about. Some helper function. This is my function. Lazy static. Yes. So this goes in here. Don't remove the to do. We still don't know what are we going to do. S, and now the regex. let's move this down. So we are going to do something like this. This is 0, 9 and dash several, and this is one of the parameters we want to do. I don't think I need special characters from the rec, so it's gonna be fine. Second number, third number, fourth number. Yeah. Is match returns bool? That's not what I want. Please give me something different that is not this match. Iterating over capture groups. Yeah, the thing is that I don't want to iterate over captures. I just want a single capture. Wonder, do I have let's test it. Dot captures, option captures. Yes, depending on whether it matches or not. This is gonna be expect. Okay, in case there is no problem, I'm not going to make this debug better. And hi, Patatas, hello. Your notebook keeps shutting down. Man, you have so many problems with your computers. Okay, hope that goes better over time. I don't know, but man. And then you will have cap equal this, and then in theory I should be able to do caps 0, 1, 2 and 3. So in theory this is basically returns self field struct fields pos x is cap 0, so this is the first one that comes in. Y is cap 1. Regex feels like cheating sometimes for parsing. He doesn't like me. He doesn't like me at all. 2 and 3. He doesn't like me at all. So that's not how it works. Ah, no. Yes. The problem is that it needs to be parsed into string. Of course. I mean, this parse is guaranteed to work because unless... Oh, wait. 0 is everything. So unless I mess up, this regex enforces that it needs to be a number. So it must work. The thing is that usually in regex, the capture number 0 is the whole thing. So gonna go with that because it's my experience. So it's 1, 2, 3, 4. 0 is everything. And let's do that. And hopefully we got it right. Oh yes. Okay, yes. Yes. So let's check the last one. For example, 20,1, 15,3. 21, 15,3. Good. Good. Okay. implement position. Let's here, for example, because things that we need is, for example, the Manhattan distance for self is basically self x plus self y. Return say 64. Wait, that's the absolute. What absolutes? Don't mess that up. I would like to implement ops add. For position, so we can add one to another. Output this pos is another position, and then self x is self x plus right hand side x, and then y is self y plus right hand side y. So we can add one and the other. Okay. We'll also store here the absolute bacon pos and the distance as an I64. Distance doesn't need to be A64, it can be usize or U64 because it's unsigned, but yeah, so position is this. Beacon is this. Okay, now. Oh, missing a C. Missing a C. Okay, glad I saw it. So because this position is relative, so we want to store here pos plus beacon, and this is beacon dot Manhattan distance. We have some extra info in here already parsed. Okay. Now, what do I do with this? Because it says that I need to count from the arguments. I need to get, thanks, I have the arguments here. So let target y is if args dot sample for the sample for the sample data I think is 10, else is something here. So let me double check. I don't want to be guessing here. So yes, sample is 10. Real data is this huge number. Let's put underscore. Okay, now we can read it. That's 2 million. Nice. In this way we can do this. And target y is 10, target y is 2 million. Okay. Data is there. Now, how the hell do I compute this? the hell do I compute this? First, there is a beacon here. Or a sensor, but that doesn't matter, right? So, are there 26 in here? It's like... Okay, so there are 25... What? There are 25 positions up to here? Ah, no, wait, the zero's here, the zero's here, the zero's here. Okay, okay. So, if from here to here, there are 25. Yes, from there to there are 25. And then there is 26, 27. Are you removing the beacon? Because they cannot possibly exist. Problem is that you're not telling me explicitly. Yeah, of course, if there is a beacon, we subtract that beacon, I guess. But if there is a sensor, we should not subtract a sensor. Okay, so many problems. So first what we need to do is computing the diamond for a given Y position. Because we need to repeat that for all the sensors. So thing is that we have the Manhattan distance to here, which is X, and now we need to know what is the delta on Y, and that gives me minus how many plus how many. Ooh, yeah, I think it's it. My brain is melting. 24 minutes in, my brain is melting. That is a bad signal. Yeah. So for a given target Y, so let's say. So from a sensor, coverage at Y, self Y I64 returns. I mean, I could return a range or something, but I mean, let's make it simple. I64 to I64. So it's basically from where to where. So then we get first how many did we spend horizontal, so vertically. So dy is here, doesn't matter, it's just a distance, so we're going to compute the absolute. So yeah. So this is self position Y, and now you compute the absolute here. That gives me the delta Y. then range x at y position is self distance minus dy. It's the range I can cover in one direction. So now this returns self pos x minus range x to self pos x plus range x. Sounds correct. I guess. Then we just need to get the leftmost and the rightmost of all of those. So let ranges is sensors iter map sensor dot coverage at y target y. I'm going to collect that into a vector for simplicity. And now let min x is basically ranges iter map grab me the if this is L and R, just L, copy it, and with the result you compute minimum and wrap it. There should be a minimum, must be a minimum. Yeah, let's put underscore here. Yeah, max x is the same story. Now we are using only R, and this is max, and wrap it. Debug that. Let's see how far are we on the answer. Sorry, sample data, please. Sample data. For the love of God. From minus 18 to 58? This is totally wrong. You know what is the problem? I think that when I'm computing the distance, I'm not considering that I'm out of range. I think that is the problem. I'm not considering I'm out of range. And I cannot output out of range. So this is a problem. I mean, out of range will mean negative range, which means that left is greater than right. It's better if we return an option, because we can use map filter. So, and it's more clear than doing it manually. Now if range x is less than 0, none. Because if it is 0, it's valid. It's just in the center position. That's perfectly fine. And now the advantage of this is that we can use filter map and filter all the ranges that are invalid. Does that solve our problem? No. That does not solve our problem. Epoch the ranges. What do we have? What am I missing? Something is not correct, and it's most likely the coverage at Y. Most likely is the coverage at Y. Okay, before filling with this thing with the bugs and prints and so on, let's review. So there is the difference of the amount of distance from my current position and the target position. That difference, absolute, of course. I get an absolute from that. Doesn't matter if it's positive or negative. Then we have the distance to the beacon. Unless I'm understanding this as a relative and this the absolute. Let's try. And this is the absolute, but if it is the absolute, I need to make the distance. So that could explain. -2,15. Yeah, and a lot of other same. Oh, so it is the absolute. It is the absolute. Okay, understood. That is the problem. That's the problem. I misunderstood. To beacon. So now absolute beacon is this. And now let to beacon is the absolute beacon minus my position. That is the to beacon. Now I need to implement that, and this is to beacon. That probably will fix. So this is a misunderstanding. I need to implement sub. So let's implement sub. That should be straightforward. How we subtract one position to another. Easy peasy. Is almost the same code. Now min x minus 2 to 24. Okay, let's verify. -1, -2. This is the first one. To 24, both inclusive. So this is correct. Up to here, this is correct. So the next thing is knowing how many are at this level, how many beacons are here, and for that I can just use either a hash map or iterate through them. Maybe just iterate through them. I mean, there are not that many. Why complicate stuff with hash maps and so on when we can just make an all step for loop for a few items? There are not that many. Even in the real input, it's like it's 36. There's no point of creating a hash map. Yes, so beacons at Y is sensors dot iter dot filter by sensor beacon absolute beacon value. Why are not completing me? Absolute beacon dot y equals target y. You do that and you just count. As long as there are not two with the same position, I'm fine. And I don't think there will be. Don't bring the ranges. That seems okay now. Beacons at Y 3? Oh, because there are duplicates. There are duplicates. There are duplicates. Yeah. Yeah. Because the same beacon is reported more than once. But it's the same beacon. Okay, that requires a hash set. Right, I'm thinking. Good. Okay, good. It's going good. Just doing the last part, and I need to remove duplicates here in this part for the beacons at Y. I computed this diamond mathematically, and I'm getting this size already from -2 to 24. I just need the number of beacons, of real beacons or of unique beacons to subtract it. So I need basically to map the beacon. You see on the score variables. What? Here? Those two? Yeah, it's because splitting left and right, and I want to keep the name L and R. So, but I'm not using it because I'm just choosing the left or the right. This is just to avoid having to write, the alternative is to write x.0 or x.1. I will do as well, to give it a bit more meaning, but then I have to underscore the variables. But it doesn't matter, anything will work. I don't think I need to care that much, but yeah. So this returns the beacons. Now we could collect this into a hash set. So let's say that this is a hash set of type pos. And now you're gonna complain. I knew it. So it needs derived hash and partial egg and so on for position. A position has all of that, but doesn't have hash. Okay, now that works. Yeah, I have one that is not used. We'll see, we'll use it in part 2 or something, and if not, we'll clean it before closing. But then, now this can be collected. Beacons at Y can be just len, and that should be 1. Okay, so what it is asking is no beacon. Let no beacon no beacon is max x plus 1 minus min x minus beacons at y. Doing all the math in my head, sorry, that is .len, and that might not match, because this is i64, so that should be as i64. No more complaining. No beacons is 26. Yeah, okay. There are 26 positions where a beacon cannot be present. Okay. Now, did I get it right? Did I get this right at the first try? Let's go. That's the right answer. Okay. Yeah. Love Rust. Almost no bugs so far. Very confident. Okay. Part 2 has little amount of text. Let's see. Good game. Thanks, Olki. Your handheld device indicates that a distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor. But the distress beacon must have the x and y coordinates is no lower than 0, no larger than 4 million. Okay. Patatas al Papa, what do you think about C++? Good question, Patatas. I would like to know as well. What's your opinion about C++? You love it? You hate it? Did you change your mind after learning Rust? Maybe, I don't know. Did you use it before? Let's continue reading. To isolate the distress beacon signal, you need to determine its tuning frequency that can be found by multiplying its x coordinate by 4 million and then adding its y coordinate. Oh, yes. Okay, yes, I understand that is transforming a 2D number into a 1D number. Yes, I did that before. Yeah, in the example above, the search space is smaller. Instead, the x and y coordinates can be most 20. With this reduced search area, there is only a single position that could have a beacon. X14 and Y11. The tuning frequency for this distress beacon is that. Pick the only position for the distress beacon. Ooh, okay. Let me think. I mean, with the current code, I could brute force it by iterating row by row. The thing is... Actually, my previous code was wrong. Now that I'm thinking, my previous code is wrong. But it passed the puzzle. There is a particular input for which it should fail. there is an input for which it should fail. Ah, patatas. C++, hard to do code right. Yeah. Now I'm thinking that this might hinder. I'm wondering if my assumption is correct. Hard to do super basic stuff, yeah. Yeah, you have been struggling with printing the debug of any particular thing, yeah. Because every type is different, they don't have a debug trait or something similar. We're getting a warning for assigning a negative float to a new size. A minus B can be undefined behavior. Yes, welcome to C++, where almost everything you can imagine is undefined behavior. An empty program contains no undefined behavior. But aside of that, it's very hard to make programs without UB. It's very hard to prove that it's UB free. While in Rust, I don't think there is. Oh, my brain. It's getting late. So, how do I find? No. All that is wrong. I mean, there is no point. There is no point. No, there is nothing wrong with trying. There's nothing wrong with trying. I mean, if I get it wrong, I get it wrong. I mean. If I get it wrong, I get it wrong. So the thing is, okay, we don't have target here. So what we need to do is for target, this is gonna have to be very slow, this approach. No larger than, but this number is valid. Okay. Yeah, this is, yes. So for this target, get the min max beacons at y. I don't think I need it. Let's clean it. Let's clean that. Okay. If min x is greater or equals, no, greater than 0, or max x is less than, let's call it constant size. So we're going to reuse this number several times. I64, I guess. Patata says, I remember a friend asking me help with an assignment he had to do in C++. The solution he had worked 3 out of 5 executions. Looking back at that memory code had UB, like undefined behavior. Come on, my brain. Yeah, that's kind of the thing. Okay, now I'm not using args anymore. That's fine. Cold option on wrap. Oh, that was unexpected. Yeah, because when we do 151 on wrap, they can be none. Oh. Yeah, that's because there are 0 ranges. Yes. So if it's empty, continue, please. Yeah, it takes a while, but it's not that slow. Okay, I could do release and see if I can. Yeah, I mean, with release is super fast. Okay, we're doing 4 million tests brute forcing this. But this is not correct. This is not correct. I'm not understanding the problem. Selected by any sensor, but its speaking must be data is no lower than 0, no larger than. To see how this is being seen, you need to diminish tuning frequency. We can find the data. Okay, the X and Y here can be at most 20. Okay. So let's pull it. Let z equals if args sample then is 20, else size. Okay, now you do this over sz and less than sz. We compute this and there are 0. And there are 0 because the algorithm is incorrect. At y11 minus 3 to 25, but I did misunderstand something here. 11x14 11x14, and that is because how did it pass before? How did it pass before? Because this is incorrect. What I did before. Because there are other ranges here with this sensor. There is another range that covers but leaves here one dot. And I just get from the outermost left to the rightmost right and over the whole thing. But it must be in there. Just to be sure, let's run the full thing. And it also doesn't find anything, meaning that this is a gap. It is a gap in the same way. Doesn't find anything. It's very quick, but it doesn't find anything. If I just grab this and subtract the real thing, it should work. If I subtract the real one. Man, this part of the problem is very difficult. This one is very difficult. So... on the ranges, if I could sort it, I don't need to implement the full algorithm. I can only implement something that is partially broken. It's much simpler. Sort by key. R dot 0, which is the left. Now I don't know what I'm doing. I know that I need to loop it. No, basically I need to go Richmond range. So for R in ranges, so if R, the left part, let's do here L right. So if the left part is greater than min x, it just stop. Otherwise, min x equals min x maximum right with max x. And then I need right. And now we will do the same but from the right side. Why do you don't like that one? Moved. No. You are not moving anything. I forbid you from moving my stuff. So this is basically iter ref will come from the other side. And if your right side is less than the maximum x, I think that is something like that. Max x equals max x minimum wait, maximum with the left. And no, it's maximum with the right, of course. When you do like that, it's to the right, and here is to the left, so you use both. Yes, yes. Minimum to the left. Okay, now you hate me with passion. Yes. Copy it. Come on. No? No? Iter copy it. Yes, so you can do it here, copy it. So I don't have to handle that. Now. Yes, that one is not mutable yet, yes. Now. This now is not going to be correct, but I want to see the result. It's not completely right. So min x less than max x. Should remove a few. Yeah, 11 here is the first one, but the 12, it appears here that we have 3, 4. That should not be. And with the real data, we only have 1. We only have 1. I mean, I don't really want to solve this properly. So I'm gonna bet that this is the. I'm gonna bet that this is because it should get roughly the correct value, but not exactly in all conditions. X by size, then plus y. And this is called y tuning frequency. Is max x minus 1 times size plus target y. And if this works, I'm not going to bother. I'm not going to bother with this. Like, it can be solved properly. Just like tired already. It's late. Want to finish. That's a big number. Okay, please. That is the right answer. Okay. I'm not bothering with fixing algorithms and so on. It is completely broken. Code is invalid. It will break with so many inputs. Algorithm is wrong, but it works just for real input. And algorithm here is also wrong. Somehow passes for both inputs. And that's with N. Yeah, you know the feeling, right? I mean, it's 11 p.m. It's late. Second problem. I'm already tired. I don't need that. Oh yeah, I do need that. Yeah. So yeah, satisfied. I know how it's done. I know how to fix it properly. It's like, is it worth it though? Is it worth it? Because it entails a lot of complex logic here to be done properly, branch abstraction and so on, that I know, done in the past, love those problems. I'm just like, I'm not into it at the moment. So, you know what? Good enough. And to be clear, that it's not properly solved, it's wrongly solved. But I'm not going to look back. Good enough is good enough. So yeah, we are up to day 16. We're getting ready. And Olgi, I'm still waiting for you for day 10. We'll see. I mean, maybe late next week or the other week. I don't know, but at some point we should be doing that. So yeah, you see that I already passed. Okay, this week sounds good. Nice. I already passed the curve. Most of the people failing already before reaching day 16 or passing the first star on day 16. Yeah, that's better. So yeah, now it's a matter of doing the remaining ones. I don't know, maybe I'll stream more often and try to finish all of them. I mean, if I can do like now, like doing super stream, I can finish quite quickly. It will be like 1 stream, 2 streams, 3 streams, 4 streams, 5 streams. But somehow I feel that that's not gonna happen. Some of those problems are really hard. Some of those problems are going to take me long. Also, if I'm going to stream late in the night after working, I'm not going to be able to do like 2 in a row. That's going to be too much. I need to preserve my sanity, you know. So yeah, I mean, what do you think? The difficulty of these problems have been increasing a lot. More and more, like, compared to the first one. Counting calories and so on. So like, this was just the sorting. This was trivial compared to what we are having now. So yeah, the difficulty is totally different. It's in a whole different level. Oh my god. So yeah, I don't know. I'm up for questions. Or comments in the chat. Or anything. I don't know. Because, you know, I'm not going to start on another problem. You'll be good with leaving it at day 10. Yeah, I mean, this is a good problem to do. This is a nice one. It will be hard already. I mean, it's not an easy problem, but compared with the difficulty that we are reaching now, seems easy compared to what we're doing now. Yeah, as with everything, is relative. And it seems that a lot of people has jumped day 9 into the day 10 because there is more people in the day 10 than in the day 9. And we did day 9 already, so looks like day 10 is easier. You have to understand the description again. Yeah, I mean, as before, I will work hard. I will work hard, okay, to give you a better explanation than this. Try to untie this for you and give it a better explanation. But basically, basically, we are constructing a machine that runs assembly code that basically runs two instructions, and each instruction has a cost in cycles, and we need to find out something during this run. So I mean, it's basically reading that, interpreting the output and the number of cycles that we are taking, and yeah, reading those cycles and so on, and summing those 6. So yeah, doesn't sound complicated. It can be explained. It will not take that long. Hopefully, it will not take that long. So yeah, that's okay. Day 16, on the other hand, is kinda hard. And sorry, 17. Wow. And jet patterns and gas and rocks falling. Wow, another hard one. Yeah, they are harder and harder and harder. So yeah, that's what it is. And anyway, basic up geometry, nice. Flatten, nice. That has been nice. And we also use a bit of regex today. Good. Yeah. So yeah, I mean, if there are no questions, nothing more, I'll close the stream in here. And I will take that as a no and close the stream. Well, see you. Thank you, Jorge.